no wonder we need these sort of trainings. And while we're not coming out and really able to give you a lot of absolutes, you know, trying to help things along. My animation already happened? All right, let's. Oh, no, it didn't yet. Okay. There's a few things that can happen in a DAS system that it's nice to be aware of. Okay, I mentioned that one of the things that's nice, you have no control over because the general contractor is going to pick the DAS integrator, but you have two types of DAS integrators out there. You've got the ones that are the professionals. They have been in the RF business. They have the equipment. They may not necessarily do their own designs. They may count on an outside firm to do the design work, and that's fine. I did a couple thousand designs for integrators. And then there's two chucks in a truck. We've all seen them, I'm sure, in the fire alarm business as well. And the challenge is there. So that is a bit of a challenge here as well, because there's some companies out there that are seeing this, ooh, the next big thing. Let me get into that and make some money. And they don't even know how to spell RF or how to use a spectrum analyzer. I'm sure within your communities, you have ways to spread the word. You can't officially recommend or unrecommend somebody, but this is one area where the skill, the RF knowledge, the engineering knowledge of the integrator is especially important. Because RF, we can't see it, we can't smell it, we can't hear it, but we need to have, as designers and integrators on my side of the industry, we need to have some concept as to how it works, how it behaves in the building, and some of the dangers that exist if I don't understand these sort of things. Right? So we talked about the directional antennas for the donor. One of the reasons we use those is because they send most all the RF power out the front and very little out the back. So that lets us put an antenna on the edge of the building with the back of that antenna facing the building. If there's not enough separation between the outdoor antenna and the indoor antennas, we get oscillation. So to explain oscillation, what happens, it's kind of like, it's exactly like taking a speaker, ampliphone, microphone, you set the mic next to the speaker, you get that squeal. Okay, that's just that little bit of audio noise getting picked up by the microphone, and then it gets louder and louder, and within milliseconds, it's just squealing. So it's just putting out noise all over the place. Same thing happens in the BDA system if they're not set up right. And what happens when we do get oscillation is that donor antenna is putting out maximum RF power pointed right at your radio tower. And City of Miami had one of their sites go down for 3 days while they tried to find the source of the interference. That was 2-mile radius, no coverage, because of some guy that installed the BDA wrong. So one of the things that we need to understand in the inspection, and even in NFPA, it says your isolation shall be 15 dB greater than the gain of the BDA. So that's what that means is, okay, we've got some signal going out. A little bit of that signal is picked up by one of the indoor antennas. It gets routed back to the BDA. It gets amplified, and then now you got big signal just shooting out at your tower site full time, because it's just a loop. But that speaker is pointed right at your tower. You don't want that to happen.